Well, welcome to another riveting CAN diagnostic episode. In today's video, we have got an adblue pump of a Euro 5 DAF LF55. Fit this to the Euro 4s, Euro 5s, DAFs, and some other vehicle manufacturers also. It's basically what they call it. This is a dosing module, so this is what calculates how much adblue needs to be injected, and then it actually injects it, pushes the adblue out to the ejector. I've just got the main connection, in, out, return, and this is the air valve, and this has got a direct short to ground on the power side. Basically this vehicle was jump started backwards. This pump was working great beforehand, but no longer works. As soon as you put a fuse in it, pop the fuse straight away. So you can't see it off camera, but I've got the power supply set up to 28 volts. And what I'm going to do is this valve here, this air valve, I'm just going to test this first. All it is 28 volts with about half an amp of current. I'm just going to touch it, and you should hear the valve open and shut. It should, and it should be quite loud really. So here we go first. Okay, so we know the air valve, the solenoid in there is great. Now, when I do the same to the actual pump, to the modulator, nothing happens. It cuts the power supply out. So it's a dead short, okay? And there you are, it's cut it out. It's climbing well up to over an amp there, about 1 volt. Which is not good. So we're going to dismantle this and see if we can repair it. The vehicle's already fixed and done. It was not, luckily, because we change these so often, we had one sitting around that I previously built, and see if it was like an air problem inside here, it was leaking. There was no drive going to it, coming out of it, so it would add all the powers and grounds and communication, and yet still no adblue was coming out. Usually it means the belt's broken there, or there's a blockage in the actual pipe mechanism, and usually I wouldn't bother repairing those. But seems that this is electrical, and only electrical on the motherboard, well, I would hope. We're going to have a go. Now these screws that hold them in, there's 4 of them, and they are called TRX bits, security bits. I've never known them on anything else other than these, although I believe some BMWs have them. Okay, so that's all I've done before, is take this cover off. I've not gone any further into this pump, but as you can see, obviously this is our controlling ECU. This is the controller. We have the motor, and then we have this this mechanism here that's going to push this plunger up and down, and that gives us the momentum for the to dose the actual adblue. You can see as we spin this, that plunger goes up and down and spurts a bit of adblue all over my desk. Okay, and then there should be what I believe would be an RPM sensor here looking at the wheel. So first things first, I'm going to remove this board and just put it on the bench away from the rest of the system. We want to as least in the way as possible. So I'm going to probably do this off camera because I don't know how long this is going to take. Okay, so she's out. What I'm going to do is, like you see, I'll put the powers and ground back on. I'm going to turn the power supply back on, and you can see what gets hot basically. Yeah, so power supply on, and it's 1 volt at 2 amp, which is a lot. Well, I don't know how well. This is, can you see that red spot on the board? So I'm going to bring this down, bring the image clearer so we can see exactly which component. and as we can see there, it's a voltage regulator. Okay, let's put that away. Let's turn the power supply off before that regulator blows up in my face. So let's take this off. Right, give me something to point with. Okay, so we've got a voltage regulator here. So this, let's get some focus. This sort of area here will be the main input. Okay, so the pair will come in through here. And we've got 3 diodes here, big diodes. These are basically TV diodes, quite common in DAFs. They fit these in the ECUs, Continental, Motorola, and in the VIC units. There's several of them. So we'll test these just to make sure these are not shorted. My guess is at least one of them is going to be shorted. We're going to have to try and figure out which voltage regulator this is, because there are many of them. And then we'll have to go through just these sort of capacitors here and these around here, and just check these resistors just to make sure that none of them have gone down. Some of these little diodes here. We'll check those with a meter and then try it again, basically see what else is, if anything else is getting hot even after we take this out. So, right, so we're going to go straight with the meter and we're going to put it in continuity mode, so we should hear the buzz. So with these TV diodes, we don't want continuity between the positive and the earth, which the earth is basically the whole board. It is the negative as a return. So we put it on positive on the most, well, the point that has the potential for the biggest voltage, and then obviously the earth on the lowest. Okay, so that one's shorted. Let's try this one. That one's shorted. So there's a theory of at least one. This one looks okay. We'll dig in there a little bit because the board's covered in epoxy resin. Voltage reg. Yeah, that doesn't seem to be shorted to earth, which is good, but I wonder if it's getting warm because of the diodes being shorted. I'm not sure. I'm just going to go around these. Now we're not checking if these capacitors are working, obviously. You take them out the board ideally to check the capacitor, then use a capacitance tester. Just make sure they're not shorted. That's the only thing we're concerned about at this precise moment. Obviously if we put it together and we've still got issues, then sure. But at the minute, this here and this one are buggered. I'm going to try and get some of this epoxy off and see what flavour of diodes they are. So the TV diodes, they fit them in a multitude of different things, so they shouldn't be too hard to get hold of, providing you can match the right numbers up. Right, so I've found some that are very similar. They're not identical numbers matching, but that's going to have to do. To be honest with you, so these are going to be a bastard to take off. There's the flux. These are I'll probably end up breaking these ones off, to be honest with you. But we shall find out. Basically, the pad, which is this whole block that sits underneath it, is soldered directly to the board, and obviously it's got a big heat sink behind it, so it's very hard. It just dissipates the heat really quick. So the best thing to do is just to keep heating, and over a bit of time slightly try and prise it away. Which, to be honest with you, could be a lot easier said than done. Numero uno. Basically, I'm lifting the board up with this diode. There we are. And when the metal, when the solder gets that hot, and the tension just releases it, basically, as you saw. So let's put that away. Let's get the iron out. Oh, that's where it all goes to shit. Yeah, right. Yeah. So what I'm doing there, as you can see, putting some new solder on, some slightly lower melt solder, because it'll be lead-free solder that's on there. I'm not going to go with the low melt solder, because you really don't need it to put stuff back on like this. It's just if you've got something that's difficult to come off, that you can actually get to the pads, and obviously we can't get to the bulk of this pad underneath. So I'm going to get the next one off. No, I'm not. I'm going to put new ones on. I'm going to put new ones on because I'm not cheap. And at the end of the day, this will be sold. So there's no expense spared. These new ones, they're can't remember how much they cost. About 15-20 quid for 5 of them. The other 3 have already gone into an ECU that I've rebuilt, a VIC 3 light unit, which is basically, if you look at more into cars, that'd be more akin to your body computer. Okay, there we go. So now we've got some fresh solder on there. Get that solder molten. That's one. Too slow. Trouble is, because a big cold pad on this is just basically chilling at the second it touches, so you need to be quick. There might be a better way of doing this, to be fair. Maybe a bit side on. Don't let that go too soon. Okay, hopefully that'll be that for the hot air, because it always drives me mad. Get the iron back out. You really don't need as much flux, but I'm trying to do anything that'll make it even the max cock easier to get the job done. Problem in it, it's still, the board is that hot. Any more slight heat and it just remelts again. Okay, that's those. I'm going to let this board cool down naturally. I'm not going to do anything to rapid cool it. So no, you're not going to spray any what's it called, IPA on it or anything like that, because you can end up cracking the board if you cool it down too quick. Put the fan there. Right, so 28 volts, no current obviously because we're not driving anything. Engine's not, there's no engine here, so it can't tell us pump to do anything. So the next clip is going to be me with the Davy or the Jaltec, whichever, on a DAF, where I'm going to plug this into a DAF and we'll see if we get any fault codes, see if we've still got any codes. I just watched this back and I didn't explain why I didn't change the voltage regulator, even though the voltage regulator is what's been getting hot. Basically, it's not faulty, that's why. I tested that with a multimeter. If you watch it, you can see that it is each side, that regulator, the in and the out, is fine. The reason why it was getting so hot is because basically the voltage is backing up because the diodes were shorted together. So yeah, that's why it wasn't changed. It doesn't need to be changed. But the proof will be in the pudding when we plug this into a DAF and read what fault codes we have. It may stand corrected and it may say voltage regulator or dosing module internal error, something like that, but I doubt it. We will find out. Okay, so we're back the next day. Plumbed in the pump. I've already got, there's no lights on the dash. Normally you'd have an AdBlue light here, it's what we'd call a puff light. Let's go to engine. Error information. Okay, so no active errors. These dosing module faults and everything was from the when it was jumped backwards, reverse polarity with the the batteries with the customer. The only way to get rid of these inactive codes really is to reprogram the ECU. I'm not going to do that. Basically, it'll either get sold as a repaired but not refurbished, and you know that caveat on the not refurbished is important, because all I've done essentially is reverse the damage that was caused. I have not changed any seals, I've not changed any belts, nothing like that. So it'll either get sold off as, like I say, repaired but not refurbished, or it'll simply be kept here as a test unit. Something comes in and we, you know, 90% sure the pump's knackered, especially if it's intermittent. Best way to prove it is to put another one on and try it. So that's probably what we'll end up keeping it for, but you never know. Different circumstances need different answers. So yeah, fixed. Just going to run a couple of pump tests with it, just make sure it's giving out the correct quantities of AdBlue. I have no doubt that it will. So yeah, until next time, ta-da.